So now, in the previous lecture, we considered different circuits, examples of sequential circuit. We covered SR latch, S stand for set, and R stand for reset latch. And then we consider all of the possible combinations of an SR latch. So these were the topics that we covered in our last lecture. So we covered SR latch and blah blah blah, and we did a lot of stuff. Okay, so now today we will cover another, and then we also cover gated SR latch. So I also covered all of the scenarios of the gated. Today we will start with a new type of latch which is called as a D latch. Okay, so now what we are going to do? So basically we are now covering D latch. Okay, so now this is the block diagram of a D latch. So D latch has the inputs D, then we have an enable signal, then we have Q, and then we have Q bar. Look at the block diagram of a D latch. So this is our D latch. Okay, so if you look at here, how many inputs are there? Can anyone tell me what are the inputs to the D latch? Anyone may answer. And I'm noting the points from section one. Thomas was 5 answers. Abir was with 5 answers. So I'm not looking. Please, quick, 5 seconds. How many inputs?
Two
Two.
inputs.
Two
No,
inputs.
no answer. No answer. So basically, it's late. 2 inputs. The inputs. What are the name of these inputs?
D and enable.
Yeah, D and enable. And then we have 2 outputs. 2 outputs. And the outputs are Q and Q bar. So basically now we want to draw the reduce table. So now we want to draw the reduce table for D latch. So now we if we have these are 2 inputs, so we have in enable, and then we have the D inputs, and then we have Q, and then we have Q bar. Okay, there are two possibilities. Okay, so basically what we do, so basically what we can do, so we can have the reduced table. So we can do that, we can reduce that, delete. So we have the inputs enable. There are two values for enable. Okay, so now basically we are interested in qt plus 1. So there are two possible values of enable. Enable is equal to 1. Okay, if enable is equal to 1, so qt plus 1 will be equal to d. So what is our comment? And q bar will be d bar. And then if enable is equal to 0, what will be the value of qt plus 1? Anyone may answer? Anyone may answer? 5 seconds. Anyone? Yes?
D bar.
No. So basically, if enable is equal to 0, so it will retain its previous value, qt. And q bar t will be q bar t. So there are two comments. So we can say we are there comments. So it means that now, if we say that enable is equal to 1, if enable is equal to 1, q will track d. And if enable is equal to 0, so q will retain its previous value. Any question? Is clear or not clear? So this is how the table for the thing. So now we have to this thing. So now can you see here? This is now my enable. So the input are D and enable. The output is Q. This is D enable or Q. So if enable is equal to 1, Qt plus 1 is equal to D. And then can you see Qt plus 1 is equal to Q, which is called as the retain mode. And I will explain this with an example. Okay. So now let's assume we have different scenarios. So let's assume we have D. Now we have latch. Okay, forget about Q bar. Q bar is actually the inverse of Q. So now we have D, and then we have enable, Okay, and then we have q, and then we have q bar, but just q bar will be so basically if the input is d, and then we have enable. Okay, and then if we have this d and enable, and now we have q, and then we have q bar. Okay, and now this is my comment now. So basically what we can do, so we can put this thing in the down. So sorry, so we can put it here. So now what are the inputs? The inputs are d, and then we have enable. And now where is the rubber? So I need to see for the rubber. This rubber, stroke eraser. Okay, okay, now so let's assume if we look at now this is my time instance, so this is my time t1 is in red color. So at time t1, so let's assume the value of d is 1, and then enable is equal to 0. What will be the value of q and q bar? 5 seconds. Anyone may answer.
Q t minus 1 and Q
Yes.
bar t minus 1.
So basically what we do, so basically now what I'm going to do, so let's assume if we have enable is equal to 1. Enable, what will be the value of q and q bar? Anyone may answer. Anyone may answer. Please be quick. So basically, if enable is equal to 1, so it means that q will track d. So q track d. What is the value of d? D is 1. So q will be 1 and q bar will be 0. Any question? Okay, now let's assume we move at the time t2, and let's assume at time t2. Okay, now we move at time t2. This is my time t2. And okay, now d is 1 and enable is equal to 0. Okay, so d becomes, let's assume, 0 and enable is equal to 0. What will be the value of q? So basically, if enable is equal to 0, so q retains its previous value. What will be the value of q here? Anyone may answer.
0.
No.
Oh,
1,
1, why 1?
because from the previous state
Yeah,
it's 1.
basically, can you see here? So now we have the previous value 1 and 0. So q retain its previous value and q bar will also retain its previous value. So let's assume I'm now moving at time number t3. So let's assume at time t3. So now let's assume this is the time t3. Okay, so let's assume at time t3. The value of d is 0 and enable is equal to 1. What will be the value of q? Can anyone help me?
Q bar.
What
So
will be the value of
sorry,
q?
0, 0, 0, 0.
Q will be 0. Okay. So basically n q bar will be 1 because they are inverse of each other. So basically q track d. And now what is the value of d? D is q track. So q is tracking d, so it is 0, 1. So let's assume we are moving at time number t4. Okay. So if we are moving at time number t4, so okay, now in time number t4, so d is 0. Okay, and enable is also 0. What will be the sorry, so let's assume at time t4, d is 1 and enable is 0. What will be the value of q? Anyone may help? Now enable is equal to 0.
0.
1.
So basically it will retain its previous value 0 and then it will be 1. So q retains its previous value. Any question? Is clear or not clear? Okay, what I'm going to do, so now basically what I'm going to do is I'm putting it here. So let's assume this is the waveform of, okay. Now we have a D latch. Okay, now we have a D latch. Okay, there are two modes. Okay, there are two modes. Okay, now can you see here? Please look at here. Please look at here. So now the input is enable. Enable is shown in which color? Yes. Enable is shown in which color? Anyone may help?
Pink.
Pink color. Okay. So we have two modes. So now we have the blue mode. Please remember the blue mode. So T stand for track mode. And in a track mode, Q will track D. And then we have the retain mode. And the retain mode is now shown in green color. So R stand for, it's called as the retain mode. So please look at the color code. So this R is in green. So this is the retain mode. So this is the retain mode. This is the track mode. Clear? So Q will track D and R will retain its previous value. So we'll retain, so an R, so if it's R, so it means for R, Q will retain its previous value. Okay, now can you see here now? So let's assume we have the initial value of Q. So let's assume we have the initial value of Q is initially is 0. Q is, let's assume 1. Q is 1. Q is 0 here. We go there, we track mode. So now we go to the track mode. So when we go to the track mode, so what's the value of Q? Q will track D, so D is 0, so it means now we are in the track mode. Please remember, so let's assume the initial value of Q is 1. So Q is 1. We go into the track mode. Please remember the track mode is now in blue color. So this is the track mode. So this is now the track mode. From here to here, we have the track mode. So from here to here, we have the track mode. The track mode. Since we have the track mode, so Q is 1, D becomes 0, so Q will become 0 here. Okay, and at this point, D make a transition from 0 to 1. So then Q will become 1 here. So in the track mode, so can you see in the track mode, the waveform of Q is identically same as the waveform of D. Got it or not it? So basically, can you see here, they are same or different? Can you see? They are same or different? So they are same now. Okay, now we go into the retain mode. So now retain mode. Okay, now at this point of time, can you see here at this point of time? So now let's assume at this point of time, I call this a time T2, at time T2. At time T2, D is making a transition from a logical 1 to logical 0. So at time T2, we can say, so D is making a transition from 1 to 0. But this will not appear on the Q because now it is in the retain mode. So basically what we do, so basically now in the retain mode, so now in the retain mode is shown in the green color. So now this is the retain mode. So this is the retain mode. So this is the retain mode now. In the retain mode, so now what we are going to do, so now we are saying that in the blue color, so I'm now using the blue color. So basically Q will retain its previous value. What is its previous value? Its previous value is 1. Now again we go into the track mode. When we go into the track mode, so now we are going in the track mode. So basically D is 0 here. So it will make a transition from 1 to 0 here. And then 0. And here at time T3, D is making a transition from logical 0 to logical 1, but it will not appear on the output because it will retain its previous mode. And then when we see here, so now what is there? This is the retain mode. So this is the retain mode. This is now my retain mode. Got it or got it? So now if you look at here at this point of time, now let's assume this point of time, we enter into the retain mode. So now we go, sorry, this is a small problem. Small problem, no, it's a problem. I made a small mistake. What is the mistake?
For the track
You
mode.
kept Q as 0 in track
Okay.
mode.
Because it was 0, so basically now in the track mode, it's making a transition from 1 to 0. So basically in the track mode, it will become 1. Got it or not got it? And now we go to the retain mode. So now I'm using the blue color. So I use the blue color for this. So basically it's here and now it will become here. Got it or not got it? So if you look at the track mode, in the track mode, so this Q is very similar to D. Got it or not got it? Any question? This clear? And now it will go here 1 1 1 1 1 1 1 because it's retaining, and then you go. Any question? And then now we go into the track mode, so it will become 0. Is it clear or not clear now?
Clear.
Any question? Any question? Clear? Okay, so now there are different examples. So now if you look at here, so now what I'm going to do, so copy and then I'm making it paste here. Okay, now can you see here now in this example? So now what I'm going to do. So in this case, enable is equal to 1. D is 1 and enable is equal to 1. What will be the value of QT plus 1? Anyone may answer. Help me. This, yes. What will be the value of QT plus 1? Anyone may answer. Yes.
Yeah.
So QT plus 1 will be 1. Clear? And at time t2, at time t1, it will be 1. At time t2, what will be the value of QT plus 1? Anyone may answer.
Yeah.
Zero.
0.
It's 0. Okay, now D is 1 and enable is 0. Okay, but it will
0.
retain its previous value. What will be the output? Anyone may answer.
0.
0. Enable is 0. Now D is 1. Enable is 1. What will be the value of Q now? D is 1.
1.
1. And now enable is 1. So D is 0. So it's 0. So can you see here? This is not the track mode now. So the track mode is now okay. Now what I will do to do so basically, so this is now the track modes. For the track mode, I can use this color. So this is the track mode. And now enable is 1, the track mode. So this is now the track mode. And the track mode, Q is same as D. So can you see here? This is track mode. So Q is same. So this is D is 1, Q is 1. D 0, Q 0. Now track mode, D is 1, Q is 1. D 0, Q 0. Any question? Any question? And now we go into the retain mode. So retain mode. So the retain mode is now shown in this green color. 0. So it will retain its previous value 0. And now enable is equal to 0. It will retain its previous value, which is actually 0. Any question? All this clear? Clear or not clear? If I
Clear.
do not hear an answer, it's not a good sign.
It's clear, Professor.
Good. Thank you. Okay. Now, so now can you see here now what we are going to do? So now what I'm going to do. So now this is. Okay. Now can you see here? So now let's assume. Which mode is this? Can anyone tell me? Anyone may answer. In the green one. Green one, which mode? Anyone may answer.
Track.
And in the red we have retain mode. Can you see here? So now I'm going to the green mode. Okay, now I'm going to the green mode. So now green mode, so this waveform is almost similar to this waveform. Am I right or not? They are same or different?
Same.
Same. And in this case, are can you see here this waveform and the waveform are same or different?
Same.
Same. And now this mode, can you see here this mode and this mode, they are exactly same. And can you see here track mode? So basically it's 0 here and it's 0 here the entire cycle. And then it's a track mode. So this waveform is almost similar to this waveform. Any question? Any question? This is clear or not clear?
Clear.
Okay. Now what we are going to do? We are going to the retain mode. And now you're using the blue color. Okay. Now we go into the retain mode. Since we go into the retain mode, so this is the retain mode. And it will show its previous value. So this, what is the previous value? Previous value is 1. So we'll go into the retain mode. Now we are also in the retain mode. And we look into the previous value. What is the previous value here? Anyone may answer? 1 or 0?
0.
0. What's your good name?
لطيفة.
Latifa. Okay, I now noted your name. So Latifa. Abir has 5 answers. Thomas has 5 answers. Sidra has 5 answers. Ghala has 2 answers. Zafar has 2 answers. I'm recording all of these things. Now, if you look at here, now we are in the retain mode. So this is actually, can you see here? These are the blue color is the retain mode. What is the previous value here? 1. And if you look at here, what is the previous value here? Anyone?
0.
0. And this is how it works. Any question? Okay, please remember, in all the retain modes, in all of the retain mode, q will not change. Q will be stable. So we can say that q will be stable in retain mode. Any question? Any
Professor,
question?
how's the previous number 0?
From where?
The last one you did.
Because the last one is zero. So basically, can you see here? If I'm taking at this point of time, so q is zero here. In the whole
Isn't
time,
this
q is,
one?
huh? Why it's one?
Is it?
It's zero. It's the down. It's down.
Oh, okay, okay.
You got it or not got it?
Yeah, I got it.
This is just like, I'm saying it. Okay, it's saying this. You're confused with this thingy. You got it?
Yeah,
Got it? So everything there say
yeah,
it's the same thing. It's zero. It's the same thing above. Any question?
no.
Okay. So this is how a latch works on. Got it or not got it? So now what we are going to do? So now we are having a flip flop now. Okay. So now what is actually? So now I'll ask some questions regarding this thing. Okay. So we now covered D latch. Remember now we have a D latch here. We have a D latch here. This is my D latch here. This is my D latch here. Now we will cover a flip flop, D flip flop. So this is a D flip flop. This is a D flip flop. Okay, what is the input for D flip flop? The input for D flip flop is D. The second input is clock, and it's Q. What is the input for latch? It's D, and this enable and output is Q. Can anyone tell me the difference between the flip flop and latch? Can anyone tell me? Anyone? Anyone may answer. I may give some points.
The latch depends on the level the clock is at, while the flip-flop, it depends on the edge.
What's your good name?
Junaid.
How do you know this answer?
I missed a class last time, so I went through the PPT yesterday.
Okay. So what kind of edge are you talking about?
The edge of the clock, like going from 0 to 1 and 1 to 0.
Okay, so basically, okay. Now, if you look at the degree, okay, I will not your name. Very good, Junaid. So now, if you look at the block diagram, so there is a difference between the latch and the flip flop. Can you see any other difference between the latch and the flip flop? Looking at the block diagram, can anyone see the difference between the latch and the flip flop?
The inputs,
Yeah, can you elaborate it, please?
the latch has enable and the DFF has clock.
No, there is another difference. Okay, now let's assume if I'm saying, okay, now let's assume if I replace this clock. Okay, so let's assume I change it. So let's assume this is my latch and okay. Now let's assume we have two symbols. This is my K, this is my Q, and this is my M, and this is my J, P, this is my Q, and this is my T. This is also a D type, and this is also a D type. Which one of this is flip flop, and which one of this is a latch? Can you tell me? Because I just changed the name. I am just changing the name. Anyone may answer.
This one is flip flop.
Which one?
Flip flop because it has the arrow.
Yes, very good. What's your good name?
Mira.
Mira. Very good. Mira Al Naziri?
Yeah, Al-Mahazi.
Yeah. So basically, it's your second point. Second, you're gonna last time you also answered me. So I'm noting all the these students who are like responding. They may get some bonus points in the final, and I will reward these students. So please be attentive. Okay. So it means it now. The top one is a flip flop. Why is a flip flop? Because for here we have so if we have this symbol, the triangle symbol, not the arrow, but we call this as triangle. If we have a triangle symbol, we have a flip flop, and in the bottom this is a latch. Okay, now in the bottom, so T is connected to enable, T is connected to the enable, P is connected to D, and Q is connected to Q. And in the flip flop, K is connected to D, and M is connected to clock. Got it or not got it? Any question? This is clear or not clear?
Clear.
Okay, so now can you see here? So now I'm going to elaborate here. So the figure, the top figure. So can you see here now in this case, the top figure? The top figure is a latch, and the bottom figure is a flip flop. Why? Why? So can you see here why? So now the question is why? Question number one. Why? The top one is a latch and the bottom is a flip flop. Why?
The symbols are different.
Because the symbols are different. So basically T, so okay, so the top figure is a flip, this is a flip flop because, so the bottom is flip flop because we have this symbol, and the top is latch. Question number two. Now this is my question number two. The top figure M, M is now connected to the enable of the latch. So M is now connected to the enable of the latch. And in the bottom figure, T is connected to what? T is connected to the clock. Got it or not got it? Any question? Clear or not clear? Okay, now. Okay, so now we have a flip flop. Okay, so now we have a flip flop. Now we have a flip flop. Okay, so no, okay, please remember, this is a flip flop or latch in this thingy. This is a flip flop or latch. Anyone may answer.
Flip flop.
Flip flop.
It's a flip flop. Yes, it's a flip flop. Why it's a flip flop? Because we have a triangle there, and this flop is in the rising edge of the clock. Okay, and when there is a rising edge of the clock, can you not tell me when there is a rising edge of the clock? So in the rising edge of the clock, and remember we did it in our earlier lecture. So in the rising, if you remember, it's my first lecture. So can you see here? We have rising edge. So in this case, the rising edge is the, when there is a rising edge. Which color? Which color is the rising edge? Rising edge.
Green.
The green one. So in the rising edge, so there is a rising edge of the clock when the clock is making a transition from 0 to 1. This is the rising edge. So this is now the rising edge of the clock. Where is the falling edge of the clock? So the falling edge of the clock is here when the clock is making a transition from 1 to 0. Got it or not got it? So we have a positive pulse which is 1 and we have a negative pulse which is 0. So these are how it works. That now we can say, okay, now what we are going to do, so now we want to draw the waveform of this we want to draw the waveform of this flop, this thingy. So okay, this flip flop will work on the rising edge of the clock. Okay, rising edge of the clock. So at the rising edge of the clock, uh, we track. So Q tracks D. Clear? Okay. Now can you see here in the flip flop, all the decisions are done at the rising edge of the clock. Okay. Can you see? Highlight the rising. Can you identify in the figure anyone? I may get some points, give some points, and I will notice the name of the student. Can you identify the instances when there is a rising edge of the clock? Anyone may answer.
T0, T1, T2, T3.
What is your good name?
Junaid.
Junaid. Okay. So can you see here now? Now we have rising edge of the clock. So we have 4 rising edge of the clock in this example. So we have at T0, we have the rising edge of the clock. Now this is with the red color, red dot. Now we have the rising edge of the clock at time T1, which is the red dot. Now we have the rising edge of the clock at time T2, which is the red dot. And we have the rising edge of the clock T3, which is the red dot. Okay. Now what is the behavior of the flip flop? So Q. So what we do, so Q tracks T at the rising edge of the clock. So this is the behavior of a flip flop. So it means we can say Q track D at the rising edge of the clock. Okay, can you see here? Now let's assume the value, initial value of Q is 1 here. Let's assume Q, this is my Q, this is 1 here. Now we have the rising edge of the clock. What is the value of D at T0? Anyone may answer. What is the value of D at T0?
0.
So the value of D at T0 is, can you anyone tell me what is the value of D at T0? Anyone may answer.
0.
0. What is the value of D at T1? Anyone may answer.
1.
1.
1. What is the value of D at T2?
0.
0.
0,
Very good. What is the value of D at T3?
1,
1.
1. Very good. Very good. So now this is how it works. So now can you see now this, let's assume initial value of Q is 1. So it will track D at the rising edge of the curve. What is the value of D? Oh, it's 0. It will become 0. Okay, now this is an interesting observation. So at this time, can you see? At this time, D is making a transition from 0 to 1, but this output will not appear on the output. And we go here. Now we go to time t1. We go to time t1. What is the value of D? 1. It
1,
will become 1. Now it means that now this D is making a transition from 1 to 0 here. D is making a transition from 1 to 0 here. But this change will not appear on the output. Got it? And now we go here and now it will be 0. And then we'll go here and now it will go. Any question? Clear or not clear?
Clear.
Okay, now what I'm going to do, so this may be the question in exam. This may be the question in exam. How may I ask the question in the exam? This is very important that how will I ask the question in the exam? Okay, so now we have a rising edge of the clock. So we have two type of flip-flops. Okay, so now can you see we have two flip-flops. The one flip-flop is shown in the red color and the other flip-flop is shown in the black color. So which one is a positive edge trigger flip-flop and which one is a negative edge trigger flip-flop? Can you see the observation? Anyone may answer?
Red is positive and black is negative
Why?
because it's inverted on the black one.
So in the undertone, what's your good name?
Zafar.
Zafar. Very good, Zafar. It's your third point. So can you see here? So now we have the red one, which is the positive edge trigger flip flop, and the black one, which is the negative edge trigger flip flop. And how the negative edge trigger flip flop will work? So can you see here what we do? So what we do here? So now what I'm going to do? And please remember, now we have a decision point at the falling edge, not the rising edge. This is the negative edge trigger flip flop, because this is actually the negative edge trigger flip flop. So now what we are going to do? So now I'm copying this and I am pasting it here as you do it in your homework or sometime in midterm from ChatGPT. So this is actually a negative edge trigger flip flop. Because why this is a negative edge trigger flip flop? Because it's a and then this is a bubble there on that. Now we want to draw for Q. Okay, let's assume that the value of Q is 0, initial value of Q. We go to the negative edge after clock. What is the value of D? What is the value of D? Can you not tell me?
1.
1,
1. It will become 1 now. What is the value of D?
1 still,
1.
1. It is still 1. Now D is changing, but it will not appear on the output. Now we go to the next falling edge. What will be the value of D? T0, 2, 0,
0,
0. And then it will become what? Any question? This is clear or not clear? Clear?
clear,
Yes.
Okay. Now can you see here? So now let's assume we have, this is now some questions, and I'm going to answer these questions. So now this may be some question in exam. So we have 4 questions now. Question number 1. Is this a latch or a flip-flop? Anyone may answer.
flip flop.
Flip-flop. Yes, flip-flop. Why?
It has a triangle symbol.
Yes, it is a triangle symbol. So it means we have a triangle symbol. Question number 2. What type of flip-flop?
Negative edge.
Negative.
Okay, so no, it's not a complete answer. It is actually, so if we go here, so now my answer is, it's not.
Inverted.
No, negative edge triggered. And what is the type of D flip-flop? It is not complete answer. D type flip-flop. It can be T flip-flop. It can be other type of flip-flop. We will study it later on. So it is a negative edge triggered D flip-flop. Okay. Now what is M connected to what? M is connected to what? Can you? M is connected to what? M is connected to what?
D,
Yes, M is connected to D. And T is connected to what?
The clock.
Yes, T is connected to. Any question? Is clear or not clear? Okay. Okay. Now, question number 5. Is this clock is okay? Is this flip flop Q will track D at what? Which edge of the clock?
Rising edge.
Negative.
Negative.
No, who said
Falling
rising? So
falling
this
edge.
is a mistake. Please
So for
be attentive. This is a mistake. So it will operate at falling edge of the clock. Some student said rising is not a problem. You may make mistake, no problem. But you should not repeat these mistakes in your midterm. Okay, very good. At least you contributed. Who said rising? I really appreciate it. At least you are contributing. So since this block, you will track D at the falling edge of the clock. Why at the falling edge of the clock? Because there is a bubble here. Any question? Clear or not clear? Clear? I'm not hearing a response. This is not a good sign.
Yes, yes, yes.
Yes.
Okay, good.
yes.
Okay, now can you see here? So now what? Now we can say here. So we covered this one, this negative edge trigger. So now if you see here, so now what we see here. So now what you are going to do? Okay, now let's assume we have a Q here. So let's assume the initial value of Q is 1. Initial value of Q is 1. Okay, Q will become 0 here. Q will become 0 because it's a falling edge of the clock. So Q is 0, 0, 0, 0, 0, 0. Okay, now during this time, D is changing. In the blue, in the black thing, D is changing. In this small color, D is changing. But this change will not appear on the output. And still Q will be 0 here because it tracks D at the falling edge. And here is D is changing, but it will not appear on the output. And then the output will be 1 here. This is clear or not clear? Clear?
Yes, clear.
Very good, very good. So now I will have like some now examples, and these may be the question in exam. So these may be the question in exam. Got it or not got it? So basically, okay. At this the at the previous case we studied in the previous example we studied a D flip flop, but now we are studying another flip flop which is a JK flip flop. Got it or not got it? So now we will answer some question based on the block diagram. Based on the block diagram. So this is the question number 1. What type of flip flop is this? Can anyone answer?
Positive edge triggered flip flop.
What type of flip
JK
flop?
type flip flop.
What type of flip flop? So we can say okay, JK flip flop. Got it or not got it? What type of flip flop? JK. No problem. Rising or falling edge?
Rising edge.
Rising edge. Why rising edge?
Because it's just a triangle symbol.
Yes, only triangle. And JK flip flop, why because it's not a latch. Why? Because there is a there is a triangle signal. Why rising edge? Because this is a triangle with no bubble. Got it or not got it? How many inputs are there?
3.
3. What are the name of these inputs?
JK and the clock.
How many outputs are there?
2.
2. Q and Q bar. Any question? 2 outputs. Just looking at the block diagram. Got it or not got it? Any question? Please remember, whenever we talk about the clock, So in clock, we have four values. Remember, we have a positive pulse, which is represented by logical 1, a negative pulse, which is represented by logical 0, the rising edge, which is represented by the red color in this example, and the falling edge, which is shown in the blue color in this example. So this is the falling edge. So the falling edge is making a transition from 1 to 0. The rising edge is making a transition from 0 to 1. When the clock is making a transition from 0 to 1. The positive pulse is a logical 1 and the negative pulse is a logical 0. And it's already been shown here in my first lecture. Remember, you say all the sequential circuits operates on a clock, and all these clocks are shown here. If you remember, so this is the clock shown here. So this is the positive pulse 1. The negative pulse, it is 0. The rising edge is in red color, so the rising color is in red color, and the falling edge is in black color. So this is the falling edge. Clear? So now these are four different notations of the clock waveform. So we have the positive pulse, the negative pulse, the rising edge, or the falling edge. This is clear or not clear? If this is clear, I can proceed further. Anyone? Okay. Now, how the JK flip flop works? How the JK flip flop works? So, JK flip flop has, please remember, it has three inputs, and now this is the table for this. Okay. So, if J is X and K is X, X means don't care. Please remember, X means don't care. So, if the clock is 0 or the clock is 1 or the falling edge of the clock, so QT plus 1 will retain its previous value. You got it or not got it? Any question? Okay. Now you say if J is 0 and K is 1 and there is a rising edge of the clock, so we say Q will be set to 0. We call this as set. So it means 0. So K stand for reset and J stand for set. Okay. If it's 1, J is 1 and K is 0 and there is a rising edge of the clock, what will be the value of Q? Because it stands for set. Anyone? What will be the output? If it's set.
For which one, Professor?
For J is 1, K is 0 and there is a rising edge of the clock.
What?
1, because it's set. So this is called as reset Q. Reset Q. This is called as set Q. And there is a rising edge of the clock. Okay. And set is 0 and reset is 0. J is 0 and K is 0. What will be the value of QT plus 1? Anyone?
1.
No. 0, 0. No, not neither reset nor set.
Isn't it retain?
Yes, it will retain Q,
Okay,
which
I
is
was saying
QT.
from the previous state.
Okay. And 1, 1. Okay. Now please remember 1, 1. And there is a rising edge of the clock. What will happen? Anyone may answer. Yeah.
Invalid.
No, it is not invalid in case of the JK flip flop. It is not invalid. It is actually QT bar. It is the invert of the previous value. Got it or not got it? Any question? Okay, I will
Professor,
explain this with. Yes, please go ahead.
I don't get the set and reset part.
Which one? The
The
last one?
reset and set.
The reset. Okay, now can you see here? Okay, please remember J stand for set and K stand for reset. So R is now 1. So R is 1, we are resetting Q. Here, J is 1, so we are setting Q. You got it or not got
Okay.
it?
Yes,
Clear or not clear?
clear.
Okay, now what I'm going to do, so I'm going to make an example. So because examples are always good. Examples are always good. Okay, so now let's assume I'll give an example because we will go with the examples and you will understand everything what's going on. Got it or not got it? Okay, now this is my clock now. So I'm not drawing the clock in red. And now it's actually, let's assume it's a rising edge. And now we have 0, rising edge, rising edge, rising edge, 0, rising edge, uh, and rising edge. So now we want to find the expression for q. Qt plus 1. Got it or not got it? So now I'm going to explain it. And please remember, this is very important. So I will give you this figure. Maybe I will give some of a similar figure in the exam. And there will be one figure similar in the exam to fill this table. So up to you, your choice if you want to. And now, so what I'm going to do is I'm going to rub this off now. So this is, see, sorry. So this is now my comment. Okay, now please remember, this is very important. So J stand for what? J stand for more colors. I'm not going to do. J stand for set, and K stand for what? Reset. Okay, now J is 1 and K is 0. There is a rising edge of the clock. What should we do? What should we do? We'll have QT plus 1. Anyone may answer. Anyone may answer.
1.
1. Very good. Why? Because what we are going to do, the comment is set Q. Why set Q? Because J is 1 and K is 0. So this is set Q. So these are all the comments here. So now can you see here? This is so basically this is set Q, this is retain and retain, this is set Q. Got it or not? Any question? This is clear or not clear?
Clear.
Okay, now what we are going to do, so now J is 1 and K is 0. Got it? What will be the output? Anyone may answer.
1.
Why 1?
It retains the value because
It
the
retains
clock
the
is
value. So now what I'm going to do, so now it retains the value. So it retains the value. So it retains. So this retain is for the S arrow. So it is actually retain Q. Now in the next cycle, got it? In the next cycle, J is 0 and K is 1, and there is a rising edge of the clock. What will happen?
0. Reset.
0. Why 0? Why 0?
Reset. K is 1.
Yes,
That's right.
because reset Q. Got it? So we are resetting it. Okay, please remember the Q bar will be the opposite of Q. So whatever the Q bar, so Q bar will be in the first case Q bar will be 0, in the second case Q bar will be 0, in the third case Q bar will be 1. So Q bar is the opposite of Q. Got it? Okay. Now we go to the next cycle and 1 1. What will happen?
It becomes 1.
It becomes 1. Why it becomes 1? Because now I'm using the blue color, so now it becomes 1, which is called as toggle Q. Toggle the Q, the previous value. It will become 1. Any question? Clear or not clear?
Clear.
Okay, now if we have 0 and 1, the rising edge of the clock, what should we do?
It goes to 0. Reset.
Yes, 0. So we can say, oh, reset Q. Now then another clock cycle. 1 0 and clock is 0. What will happen?
It retains the 0.
It will retain the 0. Please remember, this 1 0 is also 1 0, but the problem is it will retain the value. So why I'm going to do this will retain the value. So this is actually retain the value, 0. Okay, please remember, 1 stand for set 0, but the clock is 0. It's not the rising edge. So Q will only update its status on the rising edge. It will not change its status when the clock is 0 or when the clock is 1, or even with the with there is a falling edge of the clock. Any question?
Professor, I'm not getting it. It's confusing.
Why it's confusing?
I don't
Basically,
understand it.
because the thing is you forgot about this table. Why it's not confusing? Because you forgot about this table. So can you see, if you look at here, so when there is a clock is 0 or clock is 1 or falling edge of the clock, whatever is the value of J and K, they are ignored and it will retain its previous value. You got this point or not? Any question?
Yeah, I got it.
You got it? So basically,
Yeah.
whenever you have to look at the rising edge. If it is zero, clock is zero, or clock is one, or clock is down, you ignore. You got it or not got it?
Yeah.
So let's assume if the professor is like talking a lot and he's like shouting and louding and with very enthusiasm, and the students are ignoring him. When the student ignores, then we will not listen. You got it? The poor professor.
Yeah.
You got the poor professor joke?
Yeah, I got it.
Yeah, you got that too. Very good. Okay, so now the thing is, so even can you see it now at this point of time, because clock is zero, since clock is zero, very good question, very good observation. At least you are attentive. So it means that even the clock is zero. So it means that the clock is zero. So it means that it will retain Q. And then is the rising edge of the clock, and it's 1 1. What will be the output? Anyone may answer. Now there is a
One,
rising edge of the clock. Why one?
because the arrow is up, so it will
What's your
rise.
good name? What's your good name?
Latifa.
Latifa. So it's your second point. Very good, Latifa. Very good, Latifa. Okay, now if you look at here, so that's good that you are paying attention. Someone student is paying attention, I will reward him or her. So it means see if one is toggle, so it will say toggle Q. Okay, now we have 1 1, and there is a rising edge of the clock. What will happen? Anyone may answer.
Zero.
Other
Zero.
than Latifa. Yes, yes.
Zero.
Zero. Who said it? Who said it?
Junaid.
Junaid, you talk to me. You got okay. I will mark it for the third time, but not anymore. Okay, so now you can see this toggle. So it will zero. This is actually toggle Q. And now we have 1 0,
Professor, I have
and
a
there is no
question. What do you mean by toggle Q?
toggle means you are inverting Q.
Okay.
Invert the
So if
previous
it's
value.
1 1 and rising edge, you invert it?
Yeah, yeah, you invert. Yes, if it's 1 1 in the rising edge, you invert the previous value. If the previous value is one, it will become zero. If the previous value is zero, it will become one.
Okay, thank you.
Got it? So okay, now if you have 1 0 and there is a falling edge, what will happen? Anyone may answer.
Zero still.
Yes, very good. So it will retain its previous value. So now for the retain, what I'm going to do, so for the retain, I'm using the green color. So it will retain zero. So it will retain Q. Please look at the green color. When I'm using the retain, so if it's one, it will become one. For the toggle, I'm using the blue color. It will changing the value. And for the green color, it is retaining the previous value. Any question? Clear or not clear?
Clear.
And if it is 1 1 and there is a rising edge of the clock, what will happen? Anyone will answer?
One.
One. Why one?
Because it's rising.
No, it's rising, but it's toggle Q because it's 1 1. 1 means the invert of. Can you see here? This is now the type one. Any question? Any question? Clear or not clear?
Clear.
Okay. Now
Clear.
what I'm going to okay. So what I'm going to do, so I'm please what I'm going to do, I'm now giving you one question. Okay, one question, and I'm now giving 4 or 5 minutes. Please remember, please have pen and pencil. Please have a pen and pencil. Okay. Please, why I'm doing this? This may be the question in exam. So what I'm going to do, I'm giving you one question. This may be the question in exam. One very question, very similar to the exam. Very similar question in the exam. Clear? So what I want you to do, so please write your answer on your paper. Have pen and pencil. Everyone, please to take one pen and pencil and try to write your answer on on your paper, and then you compare your solution with my solution. I will give you 3 or 4 minutes. Okay. So please, everyone, have pen and pencil, and please have this uh, thing. So what I'm going to do, so now I'm going to give you a problem. So why I'm doing this, because I want you to do good in the exam. Okay. So what I want you to do good in your midterm two, which is coming like on this over this weekend. So these are the inputs. So let's assume that we have a JK flip flop. So this is a J and K flip flop, and now we have working at the rising edge of the clock, and now we have Q Q, and then we have Q bar. So we have two outputs. Okay. So now we have J, and then we have K, then we have clock, then we have Q, and then we have Q bar. So please fill this table. And please compare your solution with my solution at 10. You can start it from now. Have pen and pencil. You can start with the first entry. So let's assume 1, 0, rising edge of the clock. So you need to fill this table. So please fill this table. So this is a question. This may be the question in exam. So assume this is a question in exam. I'll provide a solution in the next slide. So please try, at least try start from now. One now. Please fill this table. This may be the question in exam. So this may be the question in exam, and now this is the solution.
Professor?
Solution, I will provide a solution here.
Professor,
Yes, please go ahead.
when you have toggle Q, do you change it from 0 to 1 or from 1 to 0?
No,
Is it
no. For the toggle, you have to change the previous value.
okay? So it just depends on what it was before.
Yeah, what was it before? Yes, yes. Very good, very good. It means you are trying. I really like it. Very good. So in the first case, if it's, can you see here J? J is set and K is reset. So it means Q will be 1 and Q bar will be 0. So if it's 1 1 toggle, so it will toggle it will become 0. Got it? I hope I
Yes,
answered your question.
yes, thank you.
Please remember, and please remember, even what do I do? Even if your answer is wrong, no problem. But you can do it later on. You can do it later on. Why your answer was wrong? Why your answer wrong? Because in the exam I will not ask the same question. I may ask a different question. I may ask not only for a JK flip flop. I may ask for a D flip flop. And for the D flip flop, I have filled all of this. I may ask for any other flip flop. And that other flip flop we may cover it in the next lecture. So I want you to be more attentive. Okay, now I'm looking at Ireland. So anyone who answer this question, they may speak to me. They may speak to me.
I finished.
What's your good name?
Abir.
Abir. Okay, Abir. When I will solve the question, so I'll ask that whether your answer was correct or incorrect. Got it? So you can verify. Okay, you can verify the table. Anyone who did it? Any other student who did it? Please try this. Please try this. This is my humble request. Yes, anyone who did it? Okay, what I'm going to do,
Yes, Professor.
yes, I'm now going to provide the solution. Okay, and please, everyone, compare with your solution and my solution. Okay, so can you see here in the first case? So now we have J is 1 and K is 0, and this is the rising edge of the clock. So it means 1 and 0. What is this? It is set Q. Okay, there is a rising edge of the clock. So 1 1, it will toggle Q. Toggle. So 1 will become 0, 0 will become 1. And 0 1, there is a rising edge of the clock. Reset. If it's reset, okay, so this is reset Q. So now I'm going to do, so this is reset Q. Reset Q. Then 0 0. Okay, retain Q. Even is 0 0 because there is a falling edge of the clock. This is retain Q, doesn't matter. And if it's 1 0 0 and again 1 0, okay, it is set. But since the clock is 0, it will retain Q. 1 1, this will toggle Q. So this will toggle. Toggle is in red color. So toggle will, it will be 1 and it will be 0. Abir, your solution is similar to my solution or different?
Similar until now.
Very good. Okay, so now if it's 0 0 1 and okay, this is 0 1, this is reset. But since there is a falling edge of the clock, so we will retain Q. Please remember, we will not retain Q. Why? Because there is a falling edge of the clock. When there is a falling edge of the clock, we will retain Q. So this will be retain Q, this will be actually 1 and this will be 0. And then we have 1 1, we will toggle. So we will toggle, so I will use the red color. It will toggle, it will become 0, it will become 1. And then we have 0 1, which is actually reset. So we say reset Q. Okay, 0 1 is reset Q. Reset Q. So this is reset Q. So reset, so it is 0 1. And 1 0, there is a rising edge of the clock set Q. So it is actually 1 0 and it is set reset Q. So please compare your solution with my solution, and if the solution is same, it's a good thing. If the solution is not same, then there is a problem.
Professor,
Yeah.
can you explain again why the 0 1 is retained Q from
Which one?
and
Because there is a falling edge of the clock. There is a falling edge of the clock, not rising edge of the clock.
oh, okay.
If there is a rising edge of the clock, then definitely it was reset. That was a trick. That was a trick that I am typically put. Any question? Okay. Now I'm giving you another question. Okay. Now I'm giving you another question, and maybe this is a question in exam. So now please look at here, and this is okay. Please remember at this point of time we okay now. Okay. Now question. This is question number 1 in exam. Copy, and then I'm going to paste it here. So if this is a question in exam, so if I change the question to a bubble here, please remember, so only thing we will cover it here. So then, all the things will change. So this basically, this is actually, this is this thing. So you look at the bubbles there. This is also in the exam. If I change it to the bubble, so the answer will be different. Okay. Now this may be another question in exam. So what I'm going to do, so I'm going to give another question in exam.
Professor,
Yes, please go ahead.
yes, can you go back to the previous slide?
This slide?
So
Yeah.
over here, the first row will be what, QT?
Because we don't know. So for that, I will give some assumption. So basically for this, maybe I will say this is the initial is 0 or 1, something like that.
Okay,
You got it or not got it?
yes.
Okay, so maybe this is a question in exam. So yeah, no, okay, just forget about this. So what I'm going to do, so I'm not just changing the description for this. So now if I'm doing here, so now since I in this thing, I may ask for a falling edge of the clock. So it's just what is this 1 and 0, and then you can proceed further. You got it or not got it?
Yes, thank
You got it?
God.
Okay, good. So this may also be the question in exam. So this may be the question in exam. So let's do we have a D flip flop, and this operate on the falling edge of the clock, and this will be a Q. So we have, let's assume the clock. Oh, what's going on? So let's assume this is my D. This is my clock. And this is my Q. Okay, let's assume d is 0 and there is a rising edge of the clock, and then we'll q, and then we have d is 1, there is a rising edge of the clock, then we have 0, we have a logical 1, then we have 0, we have logical 0, then we have 0, we have the rising edge of the clock, and then we have 1, we have logical 1, and then we have 1, we have the rising edge of the clock. What will be the output? So sorry. Oh, ho, 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 ho.
Professor, this is still flip-flop?
This is flip flop. Yes, this is a D flip flop. This is a D flip flop. Yes. Okay. Let's assume the value of D is 0 and we have falling edge of clock. What will be the value of Q? Anyone may answer.
0.
0. Why? Q tracks D. This is another flip flop. Please remember, we studied two flip flops: D flip flop and J flip flop. So Q tracks D. Now we have 1 0. Clock is 0. What will it do? It will retain Q. This is a falling edge of the clock. It will track D. What is the value of D? 0. 0 0. Retain Q. 0 0 0. Track D. Track D. 0 1 1. Retain Q. Retain previous value. 1 in falling edge of the clock. Anyone may answer. Got it or not got it? So this is a very tricky question. So this may be the question in exam. So please go through them, all of these questions.
Professor,
Yeah.
for this one, why is the falling edge considered as tracking it? Well, for the other one, it was the rising edge.
Because this is a bubble here.
Oh, okay, sorry.
See, look at the example. So can you see this is a deep flip flop? This is a bubble here. If I change the bubble, so basically the thing is whenever this thing this thing that I gave, this is the rising edge of the clock, so there is no bubble here. You got it or not got it?
Yes.
So if there is a bubble, so basically then the output will be different. I hope I answered your question.
Yes, Professor.
Professor, I have a doubt.
Yes, please go ahead.
Can you go to the previous slide? The one with the JK flip-flop, the inverted one.
Which one?
The question you gave, but then you changed it to an inverted one.
This one? Yeah.
Yeah, so 0 is the same as falling edge, yeah?
Yeah. What's the
So
problem?
shouldn't the fifth one also change?
Why?
Because it's a falling edge.
No, it's a falling edge. So it's a falling edge. So what does it matter? Did I say something say here? You want to see me the
No, he's
show me the
asking about the 0, the fifth row. It's not a
one,
falling edge,
two,
it's a 0.
4, 5. The fifth row. Clock is 0. Doesn't matter. If clock is 0, so my comment
So
is
it
if the
will
clock is
retain?
0, so it will retain, yes. It will only
Okay.
on the falling edge of the clock. Doesn't matter. You have to be falling edge. Remember, so it will be have to retain Q. Only in all of the cases, if it's a falling edge, then it will do something. Either it will set, or either it will reset, or either it will retain, or it will flip. You got it or not got it?
Got it, Professor. Thank you.
Got it? Okay, so now I'm going to solve it. No problem. I will going to solve it. So basically, since it's 1 0, so it retain. So retain. Okay, I'm not Q bar is actually so retain actually 1. 0 1 rising edge retain 1. Got it? Okay, and then the falling edge same retain because it's 0 0. It will 1. It's also retain 1. 1 1 rising edge of the clock retain. Why? This is not a falling edge. Now it's a falling edge 0 1. 0 1 is set, J stand for set and reset, so it will 0. 1 1 toggle 1. 0 1. 1. No, not 1.
Professor isn't. Yeah.
Yeah, it will retain 0. It will retain 0. It will retain 0. Got it or not got it? Any question? Clear? This is how it works. So what I'm going to do,